2013 AP BC question number 6. The first of the infinite series we're going to do. Be done without 10.4 and 10.5, which is nice. This is back, goodness gracious, 8 years ago. But it's got everything that's typical of a current problem. So first things first, read it. Function has derivatives of all orders at x equals 0, Maclaurin. Let P sub n x denote the nth degree Taylor polynomial for f about x equals 0. Notice the original is -4 and that P, the first order, equals -3. So one of the few things I do know about infinite series is that the first order would be at 0. And you might say, shouldn't that be 0? No, that's not what it means. It's centered at 0, not at x equals 0. F prime of 0, x. Therefore, P1 of 1/2 would be -4 plus F prime of 0 times 1/2 equals -3. Add 4, add 4. F prime of 0 times 1/2 equals 1 times 2 times 2. F prime of 0 equals 2. Part B, it is known that the second derivative is -2/3, third derivative 1/3. Find P3 of x. P3 of x is going to equal f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial plus f triple prime of 0 x to the third over 3 factorial. So P3 of x equals -4 plus 2x plus f double prime is -2/3 x squared over 2 plus 1/3 x to the 3 over 3 times 2. Cancel, cancel here. P3 of x equals -4 plus 2x minus x squared over 3 plus x to the third over 18. Function h has first derivative. Now I got this wrong the first time I did it, and I know what I did wrong, but that's fine. The first derivative given my h prime of x equals f of 2x. Note that h naught equals 7. Find the third degree Taylor polynomial for h about x equals 0. There's a lot of different ways to do this. I kind of liked doing the second one. We will call the function is first derivative. Find the third degree. Tell them about h about x equals third degree Taylor poly for h x equals 0. We're going to call that q of x. All right. So we know that if h prime of x equals f of 2x, q prime 3 of x equals, so that's the derivative. Now we plug in 2x for everything. -4 plus 2 times 2x minus 2x squared over 3 plus 2x to the third over 18. Yeah, that's right. And then we integrate it, which I will simplify it first, plus 4x minus 4/3 x squared plus 8/18 is 4/9, x to the third. So Q3 of x equals integral 0 to x q prime 3 of x dx plus 7. So Q3 of x equals 7 minus 4x plus 4x squared over 2, 2x squared minus 4x to the third over 9, and we're done because it's only 3. I don't care about the last term. That is one way to do it. See if I can quickly do the other way. Since h prime of x equals f of 2x, and we know that we can also do it this way. And I'm only showing this because some people might say, no, I did it a different way. I've gotten a lot of comments on that. And I am fine with that. If you do it a different way, there's nothing wrong with that. Q3, and by the way, this is correct. Done. You don't need to do anything else. Q3 of x equals h of O plus h prime of 0, x plus h double prime of 0, x squared over 2 factorial plus h triple prime of 0, x to the third over 3 factorial. You can do it this way and then use this fact right here. Where to go? Right here, h prime of 0, plug in 0, get f of 0, and run with it from there. H double prime of 0 equals 2 times f of 2x, and you can do all that. It'll get you to the same spot. So if you did it that way, that's totally fine. Good luck.